So friends, in the last example, we have seen of creating an array by using the arange function, by using basically, we can do this by using the arange functions, but there are several ways, several ways of array creation. Okay, so and this can be done by using the different functions available in the NumPy. Okay, some of the important one that we can use here, like you can say the a function name array. So you can create convert your Python array into the NumPy array. Okay, some more methods like zeros. It will create the zeros of array, and zeros one. Okay, zeros like, it will create the zeros like array, and it can so one of the function is ones. It will create an array of ones, and if you want an empty, it will create an array of empty. We have already seen the function name arange. All right, and there are some more that we basically use mostly in the machine learning. That is a linear space. Okay, and some more are the random. Inside the random, there are the random state, and there are random state. In the random state there is rand. Okay, and there are various, you can also create an array from file. Okay, so we will use some of the important function which are widely used in creating an array. Okay, so let's do this here. Okay, let's try to create a simple application, some of the simple application where we can create this array by using the several ways. So here I will just take this one. We already imported the NumPy, and here the first way, suppose you are having an array, let's say A is an array, and it is something like 1 2 3 4 and then 5. So you can create a NumPy array. Let's see, np underscore a NumPy array. I can use np dot array array functions, and here you can pass the simple array, and if you print it, you will get this array, and this is the NumPy array as we know that. All right, and you can also check out the d type, means the type. Basically, if I use here the np underscore a dot d type, here you can see it will print the int 32, because my system supporting here right now the int 32. And some other ways of doing this, you can also create an array by you can also create the complex number of an array. For example, suppose I want to create a complex number of an array, so I can use np dot array here. Okay, and now here you can define your two-dimensional array. Let's say inside two dimension, so the bracket here, and once again the bracket. This is the first axis, then second axis. All right, so let's say 1 comma 2, and second one is 3 comma 4, and you can define here the data type. So what type of data I want here, because this is the complex, so I will type here complex, and here when I run it, let's say when I run it, it will give me okay, we need to close it like this, like this, and when we run it, so here there is a difference. Okay, pardon, like this. Okay, now when we run it, so this is something like it will create a complex number. Same way, if you want to create an array of zeros, you can use array of zeros. Okay, so I want an array of zero of what is the dimension? 3 cross 4. All right, so if I type it, it will create an array of zeros. All right, or same way, if you want to create an array of ones, you can use np.one as ones here, and then you can define the dimension. Suppose I want to create the three-dimensional, so let's say the three-dimensional, and if you want to define the type, let's say I want, this time I didn't want a int 32, I want here the 16 one. Okay, and when I run it, okay, np dot int 16, okay, int 16, sorry, like this one, okay. So D type, now it's a D type, okay, like this one. D, wait a minute, sometimes it's happen, not an issue. D TYP, okay. So here once got an unexpected DTYP, my friend. This is something like this one. So you can see this is a three-dimensional one, okay. And second, if you want to create an empty array, if you want to create an empty, same way you can use here n.empty, like here, okay. Wait a minute, empty, and here you can define the size, let's say 3 cross 4, and when I run it, this is an empty array. All right, the same way what you can do, you can create other types of array by using arange. We have already gone through the arange function dot arange, okay, and here you can define the range, okay. You can define, suppose I want to define the range of 10, okay, and here you can see the 30, okay, and here the range will be of, you can see the difference here, see. So it will start from the 10 to 30 with an increment of 5. So that means it will create 4 elements. And if you want to reshape it, and we know that the 4 elements will occur, so you can, I will use the 2 by 2, okay. So you can see this will convert it into the 2-dimensional array. All right, the same way, suppose if you want to define a range. Now let's see the difference here. Suppose if I want to define a range between the floating point numbers, okay, floating point numbers means the range of the floating that has a range of the point, the floating. For example, 0 to 2 I want to define, I want this array and it should be an incremental of 0.3. Now when you see it, you can see it will start to 0, then 3, then 6, then 9, then 12, then 1.5. So here what we have done, we have used arange with the floating point argument, and sometime it is generally not possible to predict the number of elements obtained because the floating points come with the finite precisions. So in this case scenario, if we are using the floating point, it's better to use the linear space, okay. It's better to do linear space, so that will receive an argument, the number of element that we want, instead of step. So it will not follow the step, it will automatically use the number of element that particular we want. So for example, here suppose I want to use here the from NumPy, okay, NumPy we already have it here, okay. In the NumPy there is a pi attribute, okay. So you can I'm going to import it from NumPy, import pi, okay. And for this pi, let me create the linear space, okay. That should start between 0 because pi is an infinite number, okay. And if we try to use something like this, okay, you can see it will give you a linear space 0. Then you can see out here this 0 to 2 will automatically divide it into 9 times in the floating point precision. But here we are already defining the floating point, so that's why sometime the precision may lose. But here we are not using what we say, we are not using here the floating increment. Instead we are giving it a way that create a 9 element between 0 to 2, okay, precisely divided. And same thing, suppose if we want to use this floating point, let's say np dot lin space, like this one, that is, it will start from 0 to 2, okay, and each time up to 2 it will multiply by pi, okay. And same thing I want up to 9, all right. And if I run this one, okay, so here you can see when I run it, so it will give you something like this. So it will be very useful to evaluate the function that has a lots of point. In a similar fashion, you can also find out the sine, cos, tan. Suppose I want to find the value of sine of each of the element available in this array. So I will pass a complete array over here. Now you will see the sine value. See. So these are some different ways of creating an array that you can use, okay. And in the next example, we will talk about how we can print an array, okay, in the nested list, something like that, okay. So thanks for watching this, and please, my friend, don't forget to subscribe, okay, like, and comment this video. Thanks for watching it.